Lesson 1.2. Use segments and congruence. At the end of today's lesson, we will be able to successfully use segment postulates to identify congruent segments. In geometry, a rule that is accepted without proof is called a postulate, or axiom. A rule that can be proved is called a theorem. Postulate 1. The ruler postulate. The points on a line can be matched one-to-one with real numbers. The real number that corresponds to a point is the coordinate of the point. The distance between points A and B, written as AB, is the absolute value of the difference of the coordinates of A and B. AB is also called the length of segment AB. Example 1. Measure the length of segment CD to the nearest tenth of a centimeter. So let's say C corresponds to the real number 1, and point T corresponds to the real number 3.5. So to find the length of segment CD, we can take the absolute value, 3.5 minus 1, and then we get 2.5. So this is about 2.5 centimeters. When 3 points are collinear, you can say that one point is between the other two. So B is collinear. But when you have a point that is not on the same line as the two other points, then this point is not collinear. Postulate 2, the segment addition postulate. If B is between A and C, then AB plus BC will give you AC. Likewise, if AB plus BC equals AC, then B is between A and C. Example 2. The locations shown lie in a straight line. Find the distance from the starting point to the destination. So we have the total distance SD equal to segment SR plus segment RD. Then we know that SR equals 64 miles and RD equals 87 miles. Therefore, SD must equal to 151 miles. So that's your answer. Example 3. Use the diagram to find KL using the segment addition postulate. So we can take 38 and subtract that from 15, and this gives you 23. Line segments that have the same length are called congruent. Now, when we express lengths that are equal using symbols and letters, we would use the equal sign, with AB equal to CD. When we express segments are congruent, we will use the segment symbol. So segment AB and the congruent symbol and set it equal to another segment CD. That's the difference. Example 4. Plot the following points on the coordinate plane. So I already done that for you. And part B, determine whether segment FG and HJ are congruent. So we need to use the distance formula. So for segment FG, take -1, subtract 4, square it, plus 5 minus 5, square it, and you should get 5. And for HJ, take 3 minus 3, square it, plus -2 minus 3, and square it. So this we get 5. So these two segments are congruent. So yes. Example 5. Find the length of AB to the nearest 1/8 of an inch. Example 5. Find the length of segment AB to the nearest 1/8 of an inch. So here I put out a ruler for you, and we're going to use the ruler postulate and measure this segment. So this will be about 1 inch, and this point is very close to a quarter. So we would say this is about 1.25 inches. And for part B, I want you to find the segment length QS and PQ. So for QS, I would do 31 plus 30. That would be 61. And for PQ, I would do PR minus QR. So that would be PR is 55 and QR is 31. And that would be 24. Example 6 is similar to example 4. Could you try it on your own? And wait for the answer in 5 seconds. And here's the answer.